This video is about convex mirrors, what they are, and their array diagrams. So the most common example of a convex mirror that we use every day is a car mirror. So if you think about a car mirror, you always see the image in your mirror is always a car that is upright. Convex mirrors always make upright images. You always see a car that is small, right? If I measured this image height, maybe I would get 1 inch. Now, the height of the actual car is much bigger than 1 inch. So the image is smaller than the actual car. And we are always seeing a virtual image. And in the array diagram, we'll see why. These are other examples of convex mirrors that we see pretty frequently, but the car mirror is the most common. So let's take a look at the simulation and see what we got. We'll turn off the rays for a second if it's convex. So a convex mirror is pushy outy. So right now, the left side of this mirror is concave, the right side is convex. So if I move the object over there, I can see that the image over on the left is that little image of that little candle. Now, if I turn the rays on, it gets a little bit messy and confusing. So we can see that image, but we see like these weird dotted lines. So let's see what those weird dotted lines are and how we draw them. Now, in terms of the definitions of our lines or the descriptions, in your notes, they are the same. So number 1, we'll draw a ray out from the object parallel to the mirror, then through the focal point. And then number 2 will be the opposite, through the focal point first, then reflecting back parallel. So let's take a look here. So first we go parallel, now through the focal point. So remember, over here is the virtual side of the mirror. Notice that the focal point is on the virtual side because with a convex mirror, if I continue drawing this, the center of that circle is over here. And the focal point is then going to be over there too. So my line, my ray would go straight and then reflect through the focal point. Remember, just like concave mirrors, we only trace back the reflected ray. So tracing this one back, is not something I want to do. It's only the reflected ray that gets traced back. So let's take a look at the second ray. The second ray should go through the focal point. So I draw a line that if I continued that one's a little off. There we go. Would go through the focal point. But when it hits the mirror, it reflects. It can't just go through a mirror unaffected. And then I trace back that reflected ray. Then we can see the intersection is right here. Now, if you wanted to do that third line, again, you always can. Reflected ray, trace back only the reflected ray. Oops. And there you can see the purple little image. So we'd call that image virtual, we'd call it smaller, and we'd call it upright. And check yourself with convex mirrors, they should always be virtual, always be smaller, and always be upright. Again, play around with the simulation to see. So ray 1, parallel through the focal point. Ray 2, pretending like it's going through the focal point, but reflects parallel when it hits the mirror. Ray 3 is just that center and back, and we only trace the reflected rays. They all intersect at that one spot.